in the ocean. Kelp is one of the fastest growing organisms on Earth, and because it captures carbon while it grows, it becomes a really promising option for clean energy. I'm going to explain how kelp is grown and how we turn it into fuel, where the technology is right now, and what its environmental and economic impacts look like. Okay. Kelp is a type of brown macroalgae that grows in a massive underwater forest. It can grow up to 2 feet per day, which is much faster than land plants. Since kelp uses photosynthesis, it absorbs sunlight and CO2 from the water and atmosphere, storing energy as carbohydrates. Those carbohydrates can later be converted into liquid or gaseous biofuels. Okay, how kelp is grown. So, kelp doesn't need soil, fertilizer, or fresh water, or nothing like that. It grows on long ropes or nets anchored in the ocean. Farmers seed the ropes with the young kelp, and the plants naturally grow upward toward the sunlight. Because kelp absorbs nutrients directly from the seawater, we avoid the land use problems that comes with corn or soy biofuel. This makes kelp farming sustainable and environmentally friendly. It also helps remove excess CO2 and nitrogen from the ocean. How kelp becomes a fuel. So it has anaerobic digestion, so microorganisms break down the kelp without oxygen, producing methane. This is similar to how some cities produce energy from the food waste. And then there's also hydrothermal liquefaction. This method heats wet kelp under pressure and converts it into a thick oil called biocrude without needing to dry it first. That's important because drying seaweed can be expensive. This biocrude can then be upgraded into diesel fuel, jet fuel. So, technology development. Right now, kelp biofuel is in the research and early pilot phase. Several projects funded by the U.S. Department of Energy and universities are testing offshore kelp farms and improving fuel conversion technologies. Companies have produced small test batches of kelp-based biocrude, but it's not yet available on large commercial scale. So, carbon footprint. Kelp biofuel can significantly reduce carbon emissions. Growing kelp absorbs CO2 during photosynthesis, and it doesn't require fertilizers that release greenhouse gases. When the biofuel is burned, the carbon released is the same carbon that kelp absorbed earlier. That creates a closed carbon loop, making kelp biofuel close to carbon neutral. The economic impact. So, economically, kelp biofuel has potential, but it also has challenges. A positive is job creation in coastal areas like marine farming, harvesting, engineering, and all that stuff. Kelp farms are scalable and don't compete with farmland or any drinking water. The main drawback is cost, however. Offshore, all that stuff is super expensive and it requires a lot of high-tech reactors. So kelp fuel costs more to produce than traditional gases. And public awareness to keep kelp biofuel still low. Most communication comes from marine science groups and renewable energy organizations, and the data shows that biofuel is environmentally strong and sustainable. But since it has high cost, it's still early stage technology and it's not really well known. And so if funding wasn't an obstacle, the best next step would be to build large offshore kelp farms combined with floating or underwater harvesting machines. We should also expand research into hydrothermal liquefaction so the conversion process becomes cheaper and more efficient. My recommendation is to support pilot programs along coastlines, especially where kelp naturally grows on that area. With enough investment, kelp biofuel could become a major renewable energy source that reduces emissions and supports coastal economies. Thanks.